Hello ladies and gentlemen, boys and girls. My name is Mr. Do and science is my business. Welcome to Mr. Do Scienceworld, and today we're going to talk about KC calculations, that is equilibrium constant calculations. So we're going to begin straight away by dealing with solving of problems. So let's begin with question number 1. Question 1. During a research experiment carried out by initially adding 1 mole of oxygen gas and 1 mole of nitrogen gas in a 2 decimeter cube closed container at 300 Kelvin, it was found that the concentration of the NO gas present in the container at equilibrium was 0.1 mole per decimeter cube. Question number 1. Calculate the equilibrium constants for the reaction at this temperature. How will the amount of NO gas at equilibrium be affected if the pressure is increased by decreasing the volume? 2. If the catalyst is added to the reaction. Okay. So let's go straight away by calculating this particular problem that we are given. Right. We are given a situation where we have to calculate for the KC, and if you see this problem happens to be the situation number 1 that we spoke about in the first video that we did with equilibrium constants. So we're going to solve the problem. And to solve this problem, the first thing we need to do is to do what? Is to write a balanced chemical equation for the reaction. And after writing a balanced chemical equation for the reaction, we need to find out what we were given, what we know, and what is not known. Then we'll be able to do the calculation from there. So let's begin with the calculation. Okay, so this is the information that we are given. We're given the initial number of moles, we are given the concentration at equilibrium point, and we are given the volume as well. But when you look at the KC expression, we can see that it is the concentration of the products divided by concentration of the reactants. So what do we need to do? Since KC speaks to us of concentration and not number of moles, each of these number of moles must be converted into concentration. But before we do that, we need to also write the word a balanced chemical equation for the reaction. The reaction is between oxygen gas and nitrogen gas. And we can see that, okay, let me just use this double arrow, okay. So we can see that they are giving us what? The product for this is NO gas. Right. Let's check and see if the equation is balanced. This equation is not balanced because the oxygen is 2, but here it is 1. Nitrogen is 2, here is 1. So once I put 2 here, the equation is now a balanced equation. So we have seen the equation for the reaction. Once I have written the equation for the reaction, I need to convert this number of moles into concentration. So I'll find the initial concentration for the O2, that is the initial concentration, and that is going to be the number of moles divided by the volume, and that is going to give me 0.5 molar concentration. And I'll find, we can write, instead of molar concentration, we can write it as what? Mole per dm cube, because the volume is what? Is in decimeter cube. And we know that our what number of moles is also in what? In mole. So we can have it as 1 mole per decimeter cube. Right. Okay. Now that I have gotten this, let's check it and see. I need to find also the nitrogen gas. Okay, the initial concentration for that. And that is also 1 out of 2 with a 0.5 molar concentration. Now I have gotten the initial concentration for the oxygen, the initial concentration for the nitrogen, and I also know of the what? I know of the equilibrium concentration of the what? Of the NO gas. Now I need to apply ice table to solve the problem. To apply ice table, let's see, I'm trying as much as possible to manage the board. So let me use my ice table from here. So I am going to write the elements that are involved in this reaction, or the compounds that are involved in the reaction. And what I have is I have O2 and I have N2. Okay, I am using a double line to differentiate between the reactants and the products. So the product is what? Is NO. Now I have gotten this, I know what I am dealing with. So I need to look for what? The molar ratio as well. The molar ratio, if you look at the equation, it is 1, 1, 2. So this is 1, this is 1, and this is 2. What are we completing? Is ice table, so this is I, C, and E. Now that I have gotten this, what do I need to do? I need to fill the table and use it to do the calculation. Okay, let's check. Initially, we were given 0.5 moles of the what? Of the O2. So what I have is 0.5 here, and we were also given a 0.5 of the N2. But remember, we said initial stage, our product is always what? It's most at times what? 0. So in this situation, this is what? It is 0, because the reaction has just started. No product has been what? Has been formed. So therefore, the product is 0 at that initial stage. Now, let's find the what? The change and the equilibrium and complete the table. Once I'm giving this information, I should be able to what? To complete the table. What was I given again? I was given the equilibrium what? Equilibrium concentration for the NO, and that is 0.2. So NO, the equilibrium concentration is 0.21. Okay, so I've written the 0.1. For products, remember we said we are adding them because we are producing product, so they are formed, therefore we add them. It's just like when you're giving birth. If you have one child, if you give birth again, they become 2. If you give again, they become 3. So you are adding up the children. So we are adding the product. But for the reactant, if you have a bowl of rice and you begin to dip your spoon into the rice, what are you doing? You are subtracting from it. So you are taking what? You are using it. You are using it up. So using up means we are going to subtract with that as well. So here, the difference between these two, this and this, should be equal to the equilibrium. Therefore, here is plus 0.1. If that is plus 0.1, we now compare the ratios. So to compare ratios, if 2 is 0.1, what is 1? Well, we will just say that it is 0.1 divided by 2, and that should give you what? A 0.05. So here is 0.05. And this is also 0.05. Once I do that, remember, it is negative for reactants, because we said we use up reactant. So it should be negative. Okay. So if it should be negative, I am going to subtract this from this. So I have 0.5 minus 0.05. And what will that give to you? Well, that will give me 0.45. And the same thing happens there, 0.45. pardon me to put the negative sign here, so you will remember that the reactant should be negative and our what? Our product should be positive. Okay, so I've subtracted, I've gotten the table is now completed. I have gotten all the equilibrium concentration. That is what I need in the calculation. So I'll come back and then do the calculation of the Kc. What I need is to find my Kc. So if I want to find the Kc, let's go back. According to the equation that I am given, then my Kc is now equals to, they are all gases, so it is equals to the concentration of NO divided by concentration of O2 multiplied by concentration of N2. But remember, this is power 1, but this is power 2, so here must be 2. And now that I have gotten this, I can now substitute the values and solve for my Kc value. So the Kc is now going to be, I open the bracket, and what I have for O2, for N2, NO is what? 0.1. So that is 0.1 squared. And this is 0.45. And this is also 0.45. Alright. I can hear somebody ask the question, why do we use a square bracket here, but here we are not using the square bracket? Well, as I said to you earlier in the first video, we said square bracket simply implies concentration. This is the actual value of the concentration. So if I want to put in the value, immediately you are substituting the value. We don't use the square bracket again, because if you use the square bracket, it becomes like a tautology. So you are using the concentration and still using another concentration. So we don't use the square bracket when we substitute the value. Right, so let's check and see what is going to be the Kc value. Our Kc now, we work out, and what we have is 0.1 squared divided by 0.45 multiplied by 0.45. And now let's quickly check and see what is going to be the answer to that particular problem. You can see we're getting 0.05. And this is our Kc value. So the Kc for this particular problem is what? Is 0.05. That has become the Kc value. That is question number 1. Let's look at the question number 2. Question is asking us what is going to be the effect of pressure on the what? On the Kc. So they are asking if the value of the pressure changes, what is going to happen to the Kc value? Well, very obvious. If you remember, we said something. We said that in the calculation of Kc, Kc does not, or Kc is not being affected by any of the factors that affect what? Equilibrium, what? Constant, except the what? Temperature. Which means pressure cannot affect the Kc value, catalyst cannot affect the Kc value, and our concentration also does not affect the Kc value. So the only thing that affects the Kc value is the what? Is the temperature, because we said the Kc value is a constant at a particular what? Temperature. Therefore, our question number 2 is going to be what? No effect. What is going to be question number 3? We are also speaking of a catalyst. A catalyst also does not affect the what? The Kc value. So therefore, it is also what? No effect. So keep this in mind, that the only factor which affects the Kc value is the what? Is the temperature. It is only when there is a change in temperature that will affect the what? The Kc value. Okay, so let's move on to question number 2. Okay, question number 2. we are told, it said, a 0.10 moles of a hydrogen gas and an excess of sulfur powder are sealed in a 1.0 decimeter cube container at a temperature of 90 degrees. The following equilibrium has been established. And now the equation is given, which is H2 gas plus X solid, giving you H2X gas. And they said the value of the equilibrium constant Kc for this reaction is 7 times 10 to the power negative 2 at this temperature. So the question A is asking, calculate the concentration of H2S gas in the container at equilibrium. Calculate the concentration of H2S gas in the what? In the container at equilibrium. Okay, so we want to look for the concentration of the H2 gas. The first thing that we are given the equilibrium conditions, and the equilibrium conditions that we were given is 0.10 mole of what? A hydrogen gas, and a 1 decimeter cube of the what? Of the container. And the equation as well is what? Is given. Now let's write the equation. It is H2 gas that is reacting with sulfur, okay, powder, which is solid. And now this is a reversible reaction, is giving us H2S gas. So we are getting H2S gas. Okay, equilibrium value of the hydrogen gas is given, and that is at equilibrium the number of moles of H2 gas is given at equilibrium, and that value is given to us as 0.10 mole. 0.10 mole, and we were told that the volume is what? The volume is 1.0 decimeter cube. Alright, so this is what is given, and the next thing that we know of according to this is what? Is the Kc value, where is 7 times 10 to the power negative 2. Now that we know this, we can easily do the calculation, because this is the equilibrium value, this is equilibrium value. So we know that if this is equilibrium, the only thing we need to do is to do what? Is to convert the number of moles into what? Into concentration, because Kc speaks to us of concentration of H2X divided by concentration of what? Of H2. Now, I am not going to include in the solid, because remember we said in calculating for the Kc, solid and liquid are not used in the calculation of the Kc. So therefore, this is the expression for the Kc to be determined. If this is the expression and we know the Kc value, which is this, now we are given the equilibrium value of the H2, but now it is in number of moles, but what we want is the what? Is the concentration. So we need to convert this into concentration, and then do the substitution and solve for this. So let's do that quickly, guys. Okay, so I am going to find the concentration of H2 gas at equilibrium, and to find that, it is going to be 0.10 divided by the volume, which is 1.0, and when you work out this, what are we getting? This is 0.10 divided by 1.0, and that is giving us 0.1 what? Molar concentration. So that is the concentration at equilibrium for what? For the hydrogen gas. So I will go straight, do substitutions, and then make H2S the what? The subject of the relation, and solve for the concentration. So this Kc is, the Kc is given as 7 times 10 to the power negative 2, and that will be equals to this which is not known, H2S, divided by this which is known to be 0.1, and now therefore concentration of the H2X is now going to be 7 times 10 to the power negative 2 multiplied by 0.1. So we are having 7 times 10 to the power negative 2, 10 exponent negative 2 multiplied by 0.1, and that is going to give us 7 times 10 to the power negative 3 molar concentration. So the concentration of the H2X is now given as 7 times 10 to the power negative 3 molar concentration. Right, so that becomes the answer to that particular problem. Let's look at the B part of the question. B part of the question says, how will the concentration of the H2S gas calculated in A be affected if, and what they want us to do is we are to write only increases, decreases, or stays the same. And it's saying more sulfur is used, a small container is used. Right. So let's go straight to the board and solve the problem. We want to find what is going to happen to this value that we have calculated if it happens that more sulfur is used. If we use more sulfur, what is going to happen? Let's look at this. Sulfur is what? Is a solid. So if sulfur is a solid and it is not used in the calculation of the Kc, and we use the Kc to calculate for the H2X concentration, it means that the sulfur will not have effect on the what? On the calculation of the H2S, the concentration. So therefore, our answer to that particular problem should be what? Stays the same. So we will say B stays, it will stay the what? The same. Stay the same. Right. So it will stay the same because this is not used in the calculation. Therefore, if this changes, it will not affect the what? The value that we are what? We have calculated. So it will stay the same. Alright. Let's move on to look at the next one. That is, if it happens that the container is now smaller. Okay. C. If the container is smaller, what will happen? Immediately our container is smaller, it means that we are increasing the what? The pressure, because the volume is now going to do what? It's going to decrease. And remember, volume and pressure are what? Inversely related. So if the volume is small, pressure will be high. Immediately the pressure is high in the container, what is going to happen to the value that we have calculated? Well, does pressure affect the what? The Kc value? It doesn't. Okay, so let's move on and see. Since we said pressure does not affect the calculation of the Kc value, it simply implies that if we use what? If we decrease the container, it will have no effect on what? On the Kc value. And if the Kc value remains the same, therefore also the H2S value will also remain what? Unchanged. So we say what? No what? No effect. No effect, or we say what? Stays the same. Okay, I think the first one also is stays. Yeah. So stays what? The same. Alright. Now, let's move to the next question, which is what? Question D. Question D is asking what will be the effect if there is what? A change in the catalyst. Well, if there is a change in catalyst also has nothing to do. The only thing catalyst will do in this reaction is it will speed up the rate of the forward reaction and the rate of the reverse reaction. So therefore, there is also what? No effect or stays the same. Let's look at the last question, and that is the last question for question number 2, which is E. E is saying the value of the Kc decreases as the temperature increases. Use this information to deduce whether the forward reaction is exothermic or endothermic. Explain. Right. If you look at the reaction that we are given, we can see from here that the forward reaction here is what? Is exothermic. So if it is exothermic, what is going to happen? The Kc value what? Decreases. That means that what? The reverse reaction is what? Is going to be favored. And if the reverse reaction is going to be favored, what are we going to say? We'll say that what? An increase in the temperature will always favor what? An endothermic reaction. That is what we know, because if it is exo and the reverse is being favored, then it means what is being favored is the what? Is the endothermic what? Reaction. So if reverse is endo, it means the forward is also what? An exothermic reaction. Question 3. All values at equilibrium. 2NO gas plus O2 gas is giving you 2NO2 gas. A 2.0 liter bulb contains 6.00 moles of NO2 gas and 3.0 moles of NO gas and a 0.20 moles of O2 gas at equilibrium. What is the Kc? Okay, so let's solve the problem right now. The problem that we are given, this is the equation that we were given. The equation is NO plus O2 is giving you what? NO2. And then the volume is given to be this, and the equilibrium number of moles are given. So we need to convert the equilibrium number of moles of each of these into what? Into concentration, so that we can then apply the what? The Kc, or state the Kc expression, do the substitution, and solve the problem. So let's first try by converting each of these into what? Into concentration. So concentration of the NO2 at equilibrium is now going to be 6.00 divided by the volume, which is 2.0, and that is going to give you what? 3.0 what? Molar. And if you look at this, the same thing, we find the concentration of the NO, and that is 3.0 divided by 2.0. And if we have this, we're going to get 1.5 molar. And the next thing that we need to do is to find the concentration of the O2 at equilibrium, which is 0.20 divided by 2.0. and we expected that we should have 0.1 molar. And once we got this, we can then find what? The Kc from the given equation. And we know they are all gases, so they are all included in the calculation. So it's going to be concentration of NO2 squared divided by concentration of NO squared multiplied by concentration of the O2. And once we have this, we can then do the substitution and see what we're going to have. So let's do it here. If I do the substitution, NO2 is now 3.0 squared, and this is NO is now 1.5 squared multiplied by what? 0.1. And then let's take the calculator and let's see what we're going to have. Alright, so when we look at the calculator, we're going to have what? 4.0 times 10 to the power 1. So the Kc value for this given reaction is what we have calculated, which is 4.0 times 10 to the power of what? 1. Question number 4. NO gas plus O2 gas give us NO2, and we are told that there is 4.0 moles of 2 NO2 gas, and it is introduced into a 2.00 liter bulb. After a while, equilibrium is attained. At equilibrium, 0.500 moles of NO gas is found. What is the Kc value? Okay, this is the information that we are given according to the question 4. The equation is here, and we are given initial number of moles of the NO2 gas, which is 4.00 mole. The volume is given as 2.00 liters. The number of moles of NO at equilibrium is given as 0.500 moles. Remember, these are in moles, so we need to convert the number of moles into what? The concentration. So to convert into concentration, the first thing is for me to do this one, and that is going to be our concentration of NO2 at where? At the initial stage. Is given to me because this amount was introduced. So that is going to be 4.00 divided by 2.00, and when I do this, I'll get 2.00. Okay, molar. Let's look at the equilibrium. At equilibrium, we were given the number of moles of NO to be 0.55. So let's convert that also into what? Concentration. So we find the concentration of that, but this concentration is at equilibrium. So that is 0.500 divided by 2.00, and 0.5 okay, so that is given as 0.25. So we've gotten that to be 0.25 molar. Once I have gotten this, I can now go straight away and make use of my ice table and do the calculation. So if you remember, the Molar ratio is 2:1:2. So I'm going to try and squeeze my ice table to the side. I'm going to squeeze the ice table there. So if I have my ice table, I know here is the molar ratio, and this is my reactant. So if I have the reactant, we check the ratios and we can see that what we have is NO, O2, and what? NO2. and the ratios are 2, 1, 2. So ice table. Now I need to complete the table from here. To complete this table, initially I was given a certain amount of the NO2, which we have calculated that in terms of concentration, and we got 2.00 what? Molar. So NO2, right, NO2 is given initial NO2 and initial NO2. So the initially NO2 is given as 2.00, and what else is given at equilibrium? NO is also given. So at equilibrium, this is NO, it is given as 0.25. Okay, if you look at this calculation, you can see that the initial stage of our product is not what? Is not equals to 0. That means we will assume that we are looking at the what? At the reverse what? Reaction. So if you are looking at the reverse, and this, which means that this is now becoming what? My reactant, and this is becoming my product. That would be the assumption. That's the way we will look at it from. So if we assume that, then it means that the concentration of NO and O2 at the initial stage should be equal. So we will make an assumption here. Assume, okay, that what? Concentration of the NO at the initial stage is equal to the concentration of the O2 at the initial stage is equals to 0. So we make that assumption there. Once that assumption is made, then we can easily say this and this is 0. And if you are put there to be zeros, we can now complete the what? The calculations. So let's complete the calculations by looking at the what? The mole ratios and do the calculations. Well, let's check and see reactant we said we subtract. So if I am having what? 0, but now I am left with 0.25. What has happened for me to get the 0.25? Okay, subtract. So if you are going to add them, what are we going to add to this to get this? It is the same thing, so this will become what? 0.25. And then we will use a mole ratio to complete the table. To say that, okay, if 2 is giving you 0.25, what would 1 give to you? Well, and what would 2 give to you? 2 will also be what? 0.25. But this is negative, this is positive. What will this give to you? Well, it's going to be 0.25 divided by 2, and that is going to give us negative 0.125. Pardon me, I've made the thing is very small now. Okay, so this is 0.125. all right, negative of that, and this is also negative. Oh, sorry, this is positive, okay, because this is product, so it's positive. Now we need to add this to that, so we're going to get the same thing for this side. This will be 0.125, and now we need to subtract this and say 2 minus 0.25, and that is going to give you so we're going to get what? 1.75. So we've gotten this to be 0.25, this is 0.125, and this is 1.75. Now we need to calculate for what? The Kc. So to find the Kc, what do? I'm going to clean this side and we're going to complete the problem. So let's see. Kc is now going to be, this is a gas, this is a gas, this is a gas. So therefore this is NO2 squared divided by NO squared multiplied by O2 gas. Okay, Now let's do the substitution. The value of this is known, the value of this is known, this is also known. Let's look at NO2. NO2 is there. We are getting 1.75 squared. NO is now 0.25 squared. And O2 is 0.125. So let's check and see what is going to be our Kc value. Right. Okay, so when we do that, we get in what? 392. So our Kc is now what? 392. And that is the value of the equilibrium constant for the given reaction. Let's look at question number 5. The equation given is NO plus O2 giving you NO2. Said a certain amount of the NO2 was introduced into a 5.00 liters bulb. When the equilibrium was attained, a 0.800 molar concentration of NO gas was found. If the Kc value is 24.0, what is the concentration that was originally put into the bulb? Okay, so this is the information that we are given. We were told that a certain amount of the NO2 was initially introduced. A certain amount, it is not known. So we use X to represent that. So X is representing that, and V is equals to 5.00 liters. At equilibrium, we were given that NO is 0.800 molar concentration. And now the Kc is also given to be 24.0. And we are told to find this, so we're looking for X. So what do I need to do? Well, the first thing that I need to do is, straight away we need to go from our Kc, our ice table, and then use that to do the what? The calculation. So, to get my ice table, let's check and see what elements or molecules that are involved in the reaction. So we can see that we are given what? NO, and then O2. There is a separation line between the reactants and the products, and there is what? O2. Right, good. What is the ratio? The ratio is 2:1:2. Let's try and complete ice table. Now, there are certain information that are known. Initially, we are given NO2 NO2 gas, which is what? X. So this is X. And remember that immediately we know value of this, it means that we are looking at what? The reverse reaction. If you are looking at a reverse reaction, this becomes what? Our reactant. And this one becomes the what? Becomes our what? Our product. Okay. So if that is the case, then this is 0, this is 0. Let's check and see what else that we were given. At equilibrium, we were given that what? The NO is given to be what? 0.800. So NO is here. At equilibrium, the value is given to at 0.800. Right. Remember, these are products, so it is plus. Reactants becomes what? Minus. So for me to get this value, it is this plus this that gives me this. So if this is 0, then this side becomes 0. That. Same thing. So this is plus 0.800. And if 2 is giving me this, what will 1 give to you? Plus 0.400. And obviously, this side is going to be negative 0.800 because this is 2, this is 2. Same value will be used up. Okay, let's try and complete the table. We know we add these together, so here is still going to be this, and on this side is going to be what? X minus 0.800. Now I have completed the table. I know all the equilibrium concentrations, so I can find my Kc. So Kc is given. Write the Kc expression, which is Kc is now concentration of NO2 squared divided by concentration of NO squared multiplied by concentration of O2. And now I am going to do the substitution. So Kc is given to be 24.0. NO2 is given to be X minus 0.800 squared. NO is given, and NO is given as 0.800 squared, and 0.400 is given to us, so we put that also there. Now we have gotten all the values that we are looking for, but what we are looking for here is the value, which is what? The X value. So to look for X value, we need to multiply this by that, multiply by this, expand this, and do a transposition, which I believe you are all mathematics students, so that wouldn't be a problem for you to solve that. If you solve this, you should be able to get that the concentration for this X, the value of X is now going to be 3.28 molar concentration, which is the what? The initial concentration. So we can just simply say, therefore, that the initial concentration of NO2, okay, initial, is given as 3.28 molar concentration, and that is what we are looking for. Right. Right. Thank you very much. This comes to the end of this video, and thank you very much for watching the video. Please, if you have not subscribed to this channel, do subscribe to this channel and press the notification bell so that anytime we release any new video, you will be the first person to watch the video. See you next time. Bye-bye.